friends, today we are again with another video on adaptive query execution AQE. So before we start, let me ask you something. When Spark creates a physical plan, does it really know your data? Or is it just guessing based on the statistics? What if Spark could start executing, observe the real data, and then change its strategy mid-flight? So that is adaptive query execution. Now, in the previous session, we saw what AQE does. Today, we'll go deeper. We are not talking about the features that you can see in the previous video. We are now going to open the engine. So we'll understand how Spark safely rewrites the physical plan at runtime. So let's get the architecture clarity first. So Spark has two main layers. One is the logical planning, other is the physical planning. Now AQE does not modify the logical plan. Logical plan remains fixed after the catalyst optimization. Now AQE wraps the physical plan inside something called adaptive Spark plan exec. Think of it as a supervisor sitting on top of the Spark plan tree. So important mental model is logical plan is always stable. Spark plan is the one that is adaptable. So this ensures correctness while allowing the runtime flexibility. And AQE extends the catalyst. It does not replace it. Now this slide shows the internal components. Let's walk through the internal components. So adaptive Spark plan exec is the controller. Whenever Spark detects a shuffle boundary, it wraps the subtree into the query stage exec. And for shuffle specifically, it's shuffle query stage exec. Now once that stage completes, Spark collects the map output statistics. Now these are real runtime metrics and not estimated ones. So then Spark reevaluates the cost model using these actual numbers. And if a better strategy exists, then Spark rewrites that part of the Spark plan and not the whole plan. Now only the subtree after the shuffle gets rewritten. Now AQE performs localized cost-driven plan mutation. Now the question arises, why does AQE trigger only after shuffle? Because shuffle is a materialization boundary. So before shuffle, execution is pipelined and no accurate output size exists. So Spark cannot make that deterministic decisions. So after shuffle, output is materialized, partition sizes are known, data distribution is visible. So this is the first moment Spark sees the reality. And that is where AQE can think. So you understand, no shuffle means no materialization, and no materialization means no AQE. So then the question comes to our mind, who controls AQE? The answer is the brain of AQE is adaptive Spark Plan Exec. It performs four responsibilities: monitors completed query stages, it collects the runtime statistics, it reevaluates the cost model, and replaces the child Spark Plan nodes dynamically. So it does not modify the already completed stages. It only adapts the future execution. That prevents the Spark's DAG guarantees and the fault tolerance. So strategy changes, semantic does not. AQE changes the execution strategy and not the query meaning. Now, this is another question that comes to our mind, that what runtime data is collected. So when a shuffle stage completes, Spark produces that map output statistics. And these statistics include the real partition sizes, real output distribution. So this data is fed into the cost model. Now, traditional cost-based optimization is predictive. Now, AQE becomes corrective. Instead of estimating, Spark now optimizes using the ground truth. So that is the key shift from static to adaptive execution. Now, this slide shows the full life cycle clearly. So let's go step by step. Firstly, the physical plan begins execution. And execution reaches the shuffle boundary. Shuffle query stage exec materializes the output. Map output statistics are collected. Cost model is reevaluated. Spark mutates the subtree if it's beneficial. And execution continues. So this loop can happen multiple times in a single query. So that is why it is called adaptive query execution. Now this is again another question. When is query stage created? So whenever Spark encounters the shuffle exchange exec, AQE wraps it into the shuffle query stage exec. And each shuffle becomes an independent executable unit. So that unit executes, produces statistics, reports back to adaptive Spark plan exec. Think of it as a shuffle stage, like each shuffle stage as a synchronization point or a decision checkpoint. So query stage exec is the unit of adaptability. So just to summarize this architect level, AQE does not touch the logical plan. It wraps the physical plan, triggers only the shuffle boundaries, uses the runtime statistics, reevaluates the cost model, and mutates the Spark plan subtrees safely. So Spark no longer commits to one strategy before execution. It observes, it evaluates, it adapts. That is the runtime reoptimization engine of Spark 3. So if this session was helpful to you and you understood the Spark internals better, consider subscribing because next we can go deeper and even more deeper into cost model, internals, and advanced AQE behavior. So hope you find this useful. Do write in the comments and do not forget to give feedback. Thanks for watching. See you in the next time.